where I was, what till what point you will got it? Can you please help me to understand till what point you people got it, so that I can continue from the same point?
We were discussing about the variation between 10 mg TID to 60 mg twice a day.
Okay.
I mean,
Okay.
once in 2
Okay,
days.
and I was telling you that the if you see the Cmax, okay, if, the Cmax that you give that you get from 10 mg and the Cmax that you get from 60 mg, it's really high in case of 60 mg, that you understand, right? But if you look at the C average in both the dosing regimen, the C average remains same. Are you getting me? Okay, so here if you look at the diazepam, is my voice clear? Is it going smoother or
Yes, sir.
breaking?
It's good, sir.
Yes, sir.
You keep responding in between. No, I get assurance. Okay, yes, I'm audible to that side. Otherwise, I get confused if I'm audible or not. Okay, so please help me with that. So if you look at the C average, the C average remains same. So you can do that. You can do this. Okay, and even though the Cmax fluctuates, you can still do this because this is a wide therapeutic index drug. Okay, is it clear? Diazepam is a wide therapeutic index. That's why you are able to do this. You have the flexibility of changing the dosage regimen from 10 milligram to 60 milligram. Okay, just by altering the frequency. Are you getting this?
Yes, sir.
Okay, so but if you have a narrow therapeutic index drug, you are it will be very tricky to do this. Okay, you know why? Can you tell why? It is very tricky to do this.
Highest max.
Yes, Cmax will go very up. If let's say this drug is a narrow therapeutic index drug and you dose 60 mg, that will shoot up above the maximum safe concentration. That can go into the toxic range as well, right? Right. And if you are giving every other day, that means once in a 2 day, the C minimum can go very low than minimum effective concentration also, because the gap is very less. Are you following me?
Yes.
For narrow therapeutic index drug. So for narrow therapeutic index drug, if any fluctuation in dosage regimen or dose you are doing, you are supposed to monitor the Cmax and C minimum, and you're supposed to monitor the you're supposed to do the TDM ideally. Okay, that is why we do TDM ideally for those narrow therapeutic index drug. So as the dose or the dosage interval change proportionally, the C average may be the same, but C max and C minimum drug level will change. This is what we discussed. So C max is influenced by the dose, how much you give, and the dosing interval. Okay, an increase in the dose given at a longer dose interval will cause increase in C max. This is what we discussed already, and a decrease in C minimum. So because of that, there will be less efficacy or toxic effect. So in this case, Cmax will be very close or above the maximum toxic drug concentration. Are you getting the same things we are discussing about diazepam? However, C minimum may be lower than the minimum effective concentration. Same thing what I discussed. Okay, same thing I'm writing out. In the latter case, that is in case of 60 milligram or low C minimum may be subtherapeutic and dangerous for the patient, depending on the nature of drug. Okay. Did you get this? Did you get this concept, guys? Is it clear? Is it clear? The effect of when you affect the when you change the dose, how will you change the dose based on C max, C minimum, and C average? This is what we discussed here. Now we are going to look in terms of frequency. Okay, so how will you determine the frequency of the drug administration? So by this time now you have some idea how you're gonna decide the dose. You know that you will see the C average, and based on that we are going to decide the dose. And we also see if C average is related to C minimum and C maximum, and C minimum and C maximum is related to how much amount of dose you give. Okay, so that's how you have to understand Now we'll see the determination of frequency. Okay, so how often or how more often or how less often you will dose the patient, that we'll see. So the drug dose is often related to frequency, that we saw already with one example, 60 milligram every other day or 10 milligram TID. So because we are changing the dose, we are changing the frequency. So of course the drug dose depends on frequency. We have a clear concept on that. And the same thing is written here. The more frequently a drug is administered, the smaller the dose is in the C average. Okay, in case like in case 30 mg TID, this is more frequently, and we need a smaller dose to the C average. But if you this is again another example to explain the same concept. Okay? Here, let's discuss this example only. A dose of 250 milligram every 3 hours. Okay, again, similar example, the same example, just with other drug. Okay, the dose of 250 milligram every 3 hours. How much will be in 24 hours? Or okay, how much will be in 6 hours? To 500, right? In 3 hours, 250 milligram. 6 hours, 500 milligram. You can change this 250 milligram 3 hours to 500 milligram every 6 hours without affecting the steady state concentration of the drug. This is what we saw already in the above paragraph, above topic. But if the dosing interval get longer, okay, here the dosing interval 6 hours is getting longer. The dose required to maintain the average, let us see average, is correspondingly larger. We already saw these things. When an excessively long interval is chosen, the larger dose may result in peak plasma concentration that are above toxic concentration and trough concentration that are below the minimum effective concentration, even though C average will remain the same. Okay, this is what I was explaining in whiteboard. The example of C average of 100 can be achieved by C maximum of 175 and C minimum of 25. So here 25 may be lower than minimum effective concentration, and 175 may be higher than the maximum safe concentration. So if you are manipulating this, you have to keep in mind. So that is why we told C minimum and C maximum is not a good parameter to look at, but C average can be. So in general, the dosing interval for the most drug is determined by elimination half-life that we already discussed. We'll see with the example here again, example of penicillin and digoxin here. Okay. So let us see the example of penicillin here, which penicillin is very safe drug, right? We give even if we give TID, okay, for every 6 hours, every 4 hours, depending on the condition, and we give really high dose in some of the condition like syphilis, meningitis, isn't it? So penicillin is really safe drug. This is a wide therapeutic index drug and lower toxicity. So this may, because this is a lower, as we discussed, we are using the fact that we already learned, because this has lower toxic effect. This is wide therapeutic index drug. We have the flexibility of giving this as much longer interval. Okay, than because than the elimination half life. What is the elimination half life of penicillin? Can anyone tell? Quick. You should know this. It's around less than 1 hour. Okay, less than 1 hour is the half life. So it's around 0.75 hour. Am I audible? Is my audio clear? No issue, I hope.
Yes.
Okay.
Yes, sir.
So the half life is 0.75 hour of penicillin. So we look at the 0.75 hour. Okay. So half life is very less. So we can give the drug at much longer, like than their elimination half life, much longer interval, given at interval much longer than their elimination half life. We'll see here. So even if you give it much longer half life, there won't be any toxicity. But if it comes to the narrow therapeutic index like digoxin and phenytoin, this must be given frequently, okay, to minimize excessive peak and trough fluctuation in the blood. Okay, so we'll see here. So now here, by this time, you should know the half-life of a drug, okay, and then based on that, we'll try to fix the frequency, okay. So half-life of a drug is an important factor that you should be knowing. So for example, what is the half-life of digoxin? Anyone? It's right in front of your eyes. It's around 1.7 days.
Today.
No need to look into my index. So it's around 1.7 days. So the common maintenance schedule for digoxin is very low as compared to other wide therapeutic industry. You can see 0.25 milligram per day. Okay, because the elimination half-life is around 1.7 days. But if you see for the penicillin Z, mm, um, is given at 250 milligram every 6 hours. You can see this half-life. The half-life of the penicillin is just like less than 1 day, 0.75 hour. That is why we are increasing this duration. Okay, we can give it, but if you see here, half-life is more. We have to give at lower dose. Okay, so here the elimination half-life of penicillin is just 0.75 hour, and we give 250 milligram 0.6 every 6 hours. Okay, so but if you give penicillin by giving like so here if you calculate every 6 hours, right? So if you calculate how many times we are increasing the like in terms of times, in terms of time means in terms of hour, how many times we are increasing the frequency based on half-life. Almost if you multiply by if you multiply 0.75 by 8, you will get around 6. So it's almost like 8 times of its elimination half-life. 8 times of elimination half-life of penicillin, you are putting the frequency. Okay, so penicillin is given at a dose interval equal to 8 times of its elimination half-life, whereas if you see in case of digoxin, okay, it's just 0.59 times of its elimination half-life, because half-life is very long. So this value will be low. Okay, the toxic plasma concentration of penicillin G is over 100 times greater than its effective concentration. Okay, so this is the key. Okay, this is the twist. Okay, based on this fact only we are doing all this game. Okay, we know that penicillin is safe even if it is goes 100 times more than its effective concentration. It's still going to be like less risky. But when you see in digoxin case, the effective concentration is just 1.2 nanogram per ml. You might be remembering from your TDM, but its toxic level is 3 nanogram per ml. So how thin line, how the line thin, how much line thin line is there? You can imagine. Okay, so that is why the toxic concentration of digoxin is only here 1.5 times. Okay, just 1.5 times than the effective concentration. Therefore, drug with a large dose. So this is now conclusion of this whole story. This is what you need to know. So a drug with large therapeutic index drug, I mean to say wide therapeutic index drug, can be given a larger dose and at relatively longer dosing interval. Okay, so this is the moral of the story, that you should know if a drug you are dealing is having a wide therapeutic index drug, you can give it much higher dose and much longer dosing interval. Is that clear?
Yes.
Okay, so there can be instances where you have to determine both dose and dosing interval. I think you might be familiar with this formula again from your last pharmaceutics. So this formula is has involved Cmax and C minimum. Okay, so so here in this equation, you can here you need, our topic is to calculate both dose and dosing interval. Dosing interval is tau here, you know that. Okay, so we need to calculate tau here. That's why we are looking in this formula. So if you tau can be calculated um, by having Cmax and C minimum of that drug, and once you calculate the tau, you can put the value of tau in the previous equation that we had discussed in the last class, and you can calculate the dose. Okay, T0. So this is all about this chapter. Okay, how to calculate the dose and dosing